Okay, so in section 3, we're going to talk about tangent lines, rates of change, all sorts of different things. So let's go with what slope is, right? So slope, we've always learned it as, y2 minus y1 over x2 minus x1. But what really it is, it's how fast the graph, the y values change when you go over on the x-axis a little bit, right? So if you change the x value by this much, how much does the y value change? That's really what slope is. So another way to say that is it's the rate of change of the function, right? So how quickly does this change as you go over unit by unit on the x-axis? Okay, so and like I said, you've learned how to find slope. You know how to find slope since you were, I don't know, tiny, right? How long has it been since you've been finding slope? Like you were so little, right? So this sentence here, slope is defined as the rate of change. This should be like, like when somebody asks you what your name is, you don't even have to think about it. It should be like that. Like, what is slope? It's rate of change, right? So no more y2 minus y1, no more rise over run. Slope is just rate of change. So when we have a linear function, like f of x equals x plus 2, well, that's a no-brainer. I can find slope at any point, and it's super easy. Suppose, though, I want to find the slope at 3, 5, right? Well, all you need to do is you need to take 2 points near 3, 5, and you need to, apply the slope formula for that, right? So if this is 3, 5 right here, we take 2 points, okay? So we're going to take 1 point before and 1 point after, here and here, and we're going to find the slope, and the slope ends up being equal to 1, right? Makes sense? Okay. Okay, so that's easy. You could have also picked, let's say, like this point and that point. It doesn't matter because it's linear and the slope is constant, right? Okay. But what if the curve is not linear? Then this process doesn't really work. So if you have, let's say, a parabola like this, you can't really do that, right? So look at this one. We have the function f of x equals x squared, and we want to find the slope of this at the point 1, 1. Okay? All right, so let's apply exactly what we did up there to this. So here's the point 1, 1. Let me pick 2 points. I'll just make 1, 1 of the points I pick, and I'll pick this other point. That looks like a cute little point. It's on a corner, 3, 9. It's got like, integer coordinates. I'll do that. So when I find the slope there, right, it's m equals 4. Okay, but let's like really zoom in here, okay? We said we wanted to find the slope of this at 1, 1, right? At that specific point, if I just take that point, that's kind of what the slope over there looks like. Do you guys agree? So now look at that red line that we took. Is that in any way similar? Like, is that really like, are we like hitting it on the nose when we find the slope of that red line? Not at all. Like, it's not even a good approximation, right? So we're like, okay, that didn't work. So somebody's like, hey, why don't we move that second point up there closer to the first point? So now we take this and that. The real slope that we want is this one, right? And then you find the slope of that red line and you're like, okay, it's still not the same, but it looks like we're on the right track because it's getting kind of better, right? So now we move this point even closer to the original one. And look, now we take these 2 points and we find the slope between these 2 points. Now if we compare it to the actual slope at that point, do you see how it becomes a much, much, much better approximation? Do you guys see that? So now, isn't that amazing? We actually solved the problem of, even if I have a curve not a linear function, I can actually find the slope at a point, using 2 points that are very, very close to each other. So let's talk about what it is that we've done. What we saw happen is, as the two coordinate points moved closer and closer, all right? So what did we have here? When I had the 2 points, and I have this line here that intersects the function at 2 points, I call that a secant line. You guys agree? Remember secants? Okay, so that's a secant line. What I really want, though, is the slope of that green line, which is a tangent, because it only hits the graph at 1 point. But what did we see happen? As we moved that point closer and closer to the first one, the slope of the secant line became the same as the slope of the tangent line, which is what I wanted. Okay, so this is the wording that we need to take us into calculus, right? So the secant line becomes a better and better approximation of the slope. Are you okay? Okay. All right, so let's write this up. So the way in which we can do this is, suppose I have 1 point here. And now I need to select, okay, so this point is, let's say, at x, okay? What is the y value there? It's f of x, correct? Now, here is what I'm going to do. I'm going to pick another point, but to pick this other point, I'm going to go over a distance of h. So now, if the first coordinate was at x, where is the second one? X plus h. And if the y value there was x, then what's the y value here? F of x plus h. Now, if I draw this line, which is the secant line, okay, can I write the equation of the slope for that secant line? So we're going to call that the slope of the secant line. And it's going to be y2, f of x plus h, minus y1 over what? X plus h minus x. So when I simplify that, this is f of x plus h minus f of x over h. Does that look familiar to you?
Yeah, I knew this was coming.
We've kind of done this in some of the other chapters where I've just given you like a random function and I said, find f of x plus h minus f of x. And you didn't really know why we were doing that, but this is the reason why we were doing that. Okay, so what is this now? This is the slope of the secant line. Okay, now what we have to do is we have to move this point really, really close to the first point so that this becomes the slope of the tangent line. So if I move this point very, very close to the first point, what happens to this distance h? It gets smaller and smaller, and it gets approximately close to 0. Yes? So let's write that down. So to get a better approximation, okay, we're going to move the points close to each other, which means h is going to approach 0. Will h ever be exactly 0? No, because then it'll be the same point and you can't divide by that because you're going to be dividing by 0. So what do we call it when something gets really, really close to something, but it's not a, what word do we have in math? The limit. So here's what we're going to do. We're going to find the limit as h approaches 0 of that cute little equation. This is everybody's favorite equation. You thought it was the quadratic formula? Oh no, I got news for you. So that's the best equation ever. And we call that the slope of the tangent line. Okay? So where did we get this from? This was the equation for the slope of the secant line. We just added this part, which says make h almost 0, and now that becomes a tangent, and you can find the slope at a specific point. Okay? All right. So now, another thing we call that is, any questions? Yep.
How do we know where to draw like these on the graph we drew that red?
Oh, it's you'll see. Okay. You'll be told. Okay. All right. So the slope of a curve at a point, it's also called instantaneous rate of change. Right? This is our cute little formula that we just discovered together. Okay? All right. So here we go. Gabe, to answer that question, here we go. Here's the first one. Find the slope of the tangent line to the graph of each function at the given point. So the function is x squared. We need to find the slope at 2, 4. Okay? All right. So we're going to apply that formula that I circled up there. So for that, let's do a little bit of work. We're only going to do this one time. What's f of x?
X squared.
X squared. F of x is x squared. Now, f of x plus h is x plus h squared. Okay? Which means when you simplify it, and you get that, right? Okay, put your calculator away for now, please. Okay. All right, so now we're ready to apply this formula here. So the slope of the tangent line is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. So f of x plus h is this one, minus f of x all over h. Now you have to, okay, the pre-calculus part is over. Now it's just algebra. Okay, so this is going to be the limit as h approaches 0. X squares go away. So I have 2xh plus h squared over h. Okay, now, do you see how you can factor out an h?
I think this was the bonus problem.
It could have been. I tell you, I'm from your future, so I always like to, like put this in before because like it does need some time to simmer in your minds. So now those go away. So finally, the slope of the tangent line is equal to the limit as h approaches 0 of 2x plus h. Now, can we plug in h equals 0? Yep. You plug in h equals 0, and what do you get? 2x. So the slope of the tangent line is 2x. Could we have plugged in 0 before for h? You would have gotten 0 over 0 every single time. So we had to do this math before. However, I'll take your question in a second. However, we want this to be at the point x equals 2, y equals 4. So we say at x equals 2, the slope is 2 times 2, which is equal to 4. Okay, Arel, question? Huh? Yeah. Questions?
So the actual end slope is 4?
Uh-huh. Okay, so what is it that we've done here? At that point, right, suppose I drew the tangent line at that point and I kind of extended it, right? Do you see how that line actually does have a slope of 4, right? Like you have to go up 4 over 1 to get to that point. Do you see that? So that's exactly what we found, okay? All right, we're going to do another one, and I'm going to show you like 2 ways to do this one. Okay, let's see if we can do it all in one shot here. So I'm kind of going to split this and do 2 methods. So here we go, method 1. And you can do it whichever way you like in the future. Okay, so the slope of the tangent line is f of x plus h minus f of x over h.
Isn't it the limit?
Oh yeah, sorry, it's the limit. Okay, so what's f of x plus h? It's gonna be, here, I'll write it here. It's gonna be x plus h squared plus 4, right? So let's go ahead and put that in here. So it's going to be x squared plus 2xh plus h squared plus 4. Okay, minus f of x is x squared plus 4. That parentheses is so crucial there, all over h. Okay, so if I distribute this, I'm going to get negative x squared, negative 4. So what happens here? The x squares will go away. The 4s will go away. So what do I have left? 2xh plus h over h. Is that right? Oh, h squared. So now I can factor out an h. Okay. H's cancel. This is like black magic. This is going to happen every single time. If it doesn't happen, remember, the math is always bigger than us. All we are is mere mortals. The math is always bigger. So if this doesn't happen, we humans are the ones who made the mistake. So we have to go back and see where we went wrong. All right? But the h's should cancel. So now you have the limit as h approaches 0 of 2x plus h, which is just 2x. And then at x equals negative 2, the slope is negative 4. Okay, remember when we were coming up with this formula? We were the ones that were like, hey, let me just go over a distance of h, blah, blah, blah. So we were the ones that introduced h into the formula, right? That's like it's like an artificial thing that we introduced. So when you do all of the calculations, whatever artificially you've introduced into a problem, it has to all go away, okay? All right, so here is the second method. It could be a little bit shorter. If we're given the point, we can substitute it from the very beginning, okay? So for example, at x equals negative 2, f of x plus h is technically f of negative 2 plus h, correct? Right, because x is negative 2. Okay, so what's f of negative 2 plus h? So let's just put that in there. It's going to be negative 2 plus h squared plus 4. So what'll that be? 4 minus 4h plus h squared plus 4. That's 8 minus 4h plus h squared. Huh? Everybody okay with that? So remember how we're doing f of x plus h, but x is negative 2 now, so I just did it with that. Okay, so now let's do our formula. This is the limit as h approaches 0, f of x plus h minus f of x all over h. Yeah, this is what we've been using. But now, since x is negative 2, just plug them in there. So this is f of negative 2 plus h minus f of negative 2 over h. Are you guys okay with this? We're just substituting from the beginning. Okay? So now let's plug in what we have. Okay, so what was f of negative 2 plus h? It was this, right? Minus, what's f of negative 2? 8. All over h. And now look, the 8's cancel. Okay, can we factor out an h? You get negative 4 plus h over h. H's cancel. Okay, so we just get limit as h approaches 0, negative 4 plus h. And then when h is 0, what are you left with? Negative 4. Right? So do you see how like you get left with the same number? Okay? So you can do it that way or this way. Okay? All right, let's move on. Yep. Yep. Okay, so here it says find an equation for the slope of the graph of each function, not at a specific point, at any point. That means you have to leave your answer in terms of x. Okay? So this time you could only do it as like the first step, as the first method. So let's see. I'm going to have you guys do this one, right? First find f of x plus h. I'll just set it up. Right? F of x plus h is x plus h squared minus 4x plus h plus 2. So find what that is, and then you're going to plug it all into this. Okay. Okay, so here, this is going to be the limit as h approaches 0. We're going to put in this for f of x plus h. When you simplify that, you should have gotten x squared plus 2xh plus h squared minus 4x minus 4h plus 2. Is that right? Yeah. Okay. Then we're going to do minus f of x. Now it's up to you if you want to do the minus, if you want to distribute it like in one shot. But if I do minus f of x, it'll be minus x squared plus 4x minus 2. Is that okay with everybody? All right. So if you want to do it like in one shot, you obviously can. All over h. Now comes the fun part, right? All of these things should go away. So x squared, negative x squared, minus 4x plus 4x, plus 2 minus 2. Every single time, it's like black magic. That negative f of x is all going to cancel out with something here. Okay? Trust in the math, guys. It's bigger than us. So now, let's see what I have left. Now it gets messy, and students like get lost in the mess sometimes. So rewrite this. 2xh plus h squared minus 4h all over h. And every single time when you get to this point, you can't plug in 0 for h because you'll get 0, 0, 0 over 0, which is a big no-no. So every single time, though, you have to be able to factor out an h. If you don't, then we've done something wrong. So limit as h approaches 0, h, 2x plus h minus 4 over h. Now I can go ahead and put the 0 in here. So that'll equal 2x minus 4. Okay? This is the slope at any point. So from this, if I wanted the slope at x equals 0, I put it in negative 2. At x equals 4, it's 4. At x equals 6, whatever. Okay? Yep.
How does that apply to every point if it's occurring?
That's what I'm saying. So when I put in x equals 0, the slope will be negative 4. If I put in x equals 1, the slope will be negative 2. 4, the slope will be 4. Okay? It's like, it's fantastic. Okay, now this one. So we're going to have some squares. We're going to have some rational functions. We're going to have some roots. Okay, so let's take a look at this one. M is the limit as h approaches 0. All right, f of x plus h minus f of x all over h. So this will equal limit as h approaches 0. F of x plus h is just 2 over x plus h minus f of x all over h. Okay? Now, this is over 1. Okay? So take a look here. You have the top, you have the bottom. What's the common denominator of the top? X plus h. So the quickest way to do this is multiply this numerator by the common denominator, but then you have to do the same thing here. And I tell you, 70% of the time, the mistake is students will not multiply it to the bottom. Okay? So now, we've done this before, right? When you distribute this, what do you get? What do you get for the first term?
You get
2x minus 2x plus h all over h, x plus h. Do not distribute that, okay? All right, so let's see. Limit h approaches 0. Here, I'm going to get
Why don't we cancel it though?
minus 2h. Huh?
Why don't we just cancel like cross it off? It's like that.
It's a minus.
Because this is being subtracted to from...
Uh,
Okay, so here we're going to get negative 2h over h, x plus h. And look, again, the h is canceled. So this is the limit as h approaches 0, negative 2 over x plus h. What does that give you? Negative 2 over what? X squared. Okay? Now, I usually wait until much later to tell my students this. But if a friend, a sibling, a tutor, a cousin, whatever, a calc buddy, right, should tell you, oh my God, I totally know a shortcut for this. And if you try that shortcut on anything that I'm grading, 0 points. Okay? Only because you really, 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 really need to know this. Okay? Like I don't know how many reallys that was, but like I can like make it like to the power of 4. Okay? All right. So we're gonna stop right here.